So, how y'all feeling? Probably asked that already. I tend to repeat myself a lot, sorry. Welcome to physics. Now, quick, just because I'm curious, who's had a physics class before? All right. That is usually the response I get. And that is okay, because this class is designed for people who even haven't taken a physics class before. This class is called Physics of How Things Work, because the goal for this course is to help you understand what physics is and understand the basic science that affects everyone on planet Earth, regardless of whatever you end up doing professionally. So if you are unfamiliar with physics, that is okay. That is part of the class. And I am saying that as a comfort. So, welcome. Does anyone have any questions before we get started with all the fun technical stuff that we have to go through on day one? All right. So, to begin, if you haven't had physics before, let's quickly define what physics is. And physics is the study of everything, basically. To try to be a little more helpful with that, physics is the act of examining the universe around us and trying to use logic and math to understand what is happening around us and try to understand how we can utilize that to our advantage. For example, people noticed a long time ago that tends to happen, and started asking why, what information can we glean about that, what things can we calculate about that, and how could we possibly use it to our advantage. And now we know a lot about gravity, and we can use it to generate power, and we know enough about it to jump out of planes safely, which we couldn't do a couple millennia ago. So all physics is studying the universe, making observations, repeated observations over time, and trying to glean information about the universe from those observations. And secretly, you have been doing that your entire lives. You are already physicists, technically speaking, because you've lived in the universe and you've been observing how it works. Correct?
Yes.
So unless you were forged today, and this is your first day being alive, if it is, by the way, welcome. But if it isn't, you've been making observations for as long as you've been alive. All of those observations are physics, because you've noticed this happen. You've also noticed a bunch of other things, like how when a car turns to the left, you feel like you're getting pulled to the right. If you've driven before, you've kind of got a gauge on how hard you need to be pressing the gas pedal, how much you need to turn the wheel to make a certain turn at a certain speed. You've noticed that when you open the door, you want to grab the door further away from the hinge rather than try to press it here, which is nowhere near as effective. All of those little things are physics, even if you don't know the words for those concepts that physicists use. Because all physics is just making those observations, measuring them, and trying to form ideas about what we can do with that information. You've been doing that your whole life. And my objective for this course is basically to help you understand what you already know. Because nothing I talk about in this class is going to be an all new concept to you. It's all going to be stuff that you've observed before, and we're just going to put words and numbers to it. My goal is to help you understand what you already know, to make use of all those observations you've made over your entire life. Does that sound fair so far? All right. Stay hydrated, especially if you ever talk for a living. So, I don't want this course to be scary. And the thing about physics is, physics can be kind of scary, especially if you don't have a very good relationship with math, because physics is going to unavoidably be a math class, at least 50%, if not more. And the reason for that is physicists not only make observations about the universe, but we use math as a language to describe the universe. We use the numbers to try to make sense of what's going on around us. And again, if you don't care much for math, or science as a whole, again, you're allowed, that can sound kind of scary. Physics is difficult, especially if you start looking at things like quantum mechanics, which just, again, as to try to not be scary, we don't deal with quantum math in this class. You can ask about it, but we're not going to do any of it. But what I mean by physicists using math as a language, I forget which markers have ink, is that I, just having done this for 15 years, am able to look at a physics formula and tell you what every letter in it means and basically describe the narrative of how all these concepts relate to each other. Now, at the end of the course, my goal is for you guys to be able to do the same thing too. This is one of the most famous physics formulas. It's Newton's second law, which we'll be talking about in detail in a few weeks. Has anyone seen this one before? It's okay, it's all right. Couple nods. If I was to try to, again, physicists use math as a language. So when I look at a formula, not only can I do numbers with it, but I can also tell you what everything in it means using words. And if I was to do that with this formula, math-wise, it says sigma F equals m times a. But to describe it in physics language, what this formula tells us is that if you exert force on an object, all objects having mass is what the M stands for, force acting on an object causes that object to accelerate. And acceleration is a change in the object's motion. And you've noticed this before, because if you have an object and you want its motion to change, you have to exert force on it. So you know this, even if you've never used this formula to do math before. We're going to go over a lot of formulas in this class. We're going to use algebra upon those formulas. But the purpose of the algebra is to help the concepts work together. The math will always inform the concepts and vice versa. The math in this class, I'm a little biased in terms of my, sorry, words. This might sound a little bit biased towards like pure math classes, like if you just took calculus, but this class isn't going to just be a wall of math problems that you have to do the same thing to repeatedly. Any math questions I give you, I kind of think of them like logic puzzles. Like I will tell you, say, you push on a mass, how fast does it start moving? And you would use the formula with that narrative to try to figure out what's happening and use the concepts to help derive what happens next. So we use the math to make predictions, we use the math to inform the concepts, and the concepts to inform the math. So it's all going to work together. So if you don't care much for math, I promise it's going to be okay, because every new formula we go over, I'm going to talk about in words what it means and how we use it. And additionally, separately, the whole first week of this course, barring today, because today is syllabus day, we're going to be going over all of the algebra stuff that you're going to need. We're going to review, calculating order of operations, unit conversions, all the stuff that you need. This week is going to be setting the foundation for everything else to follow. Sound fair? Okay. So, I don't want any of the math to sound scary. I don't want any of the science to sound scary. To that end, I want you to ask me questions anytime anything sounds confusing. And I really do mean it. One other quirk about me to note is I'm going to stop about every 5 minutes or so, it feels like, and ask if you have questions. And I really do mean that when I say it. I want to know if you have questions. I want to know if something's confusing or if something is on your mind. Because one of the things with physics is everything builds on the last thing. Like we're spending this week working on all the math and intro concepts, and then we're going to start applying those towards forces and then motion, et cetera, et cetera. If something we're working on now doesn't make any sense, it's only going to get worse when the next thing builds on it, and so on and so forth. If you don't ask your question now, that's like building your entire house on a coconut. It's not going to go well. So I want you to ask questions when you have them. If something doesn't make sense, if you need something phrased a different way, a better example would work better for you, anything at all. Even if I'm mid-sentence talking about something else, I want you to ask, I want you to cut me off. It is better for you to ask a question and cause me to change the entire trajectory of the lecture than for you to leave this room confused. So please ask your questions. I really do mean it. Fair deal? All right. Speaking of, any questions before we move on? Yes?
Do we start lab on Wednesday?
We do not. There is no lab this first week because we haven't covered anything to use in lab, and some people would have tomorrow before we have another lecture because there's a Tuesday one and a Wednesday one. So no lab this week. Make that official announcement to everyone. We will start next week, and that first lab will be group algebra practice and going over the things we covered between now and then. Does that answer the question? Anything else on your minds? We're moving on. Okay. Again, stay hydrated. Now, before getting into the weeds of the syllabus, I want to talk at least a little bit about myself, because I'm going to be the one up here talking the entire time, so I'd like you guys to be at least somewhat familiar with the goofball that's going to be talking at you all semester. Hello again, I'm Joshua Hoffbauer, and it's nice to meet you all. A couple things about me. I'm a PC alum. I actually graduated from here with my physics degree in 2014, and it really is nice to be back. I do love this school, and it's a little weird to be standing up here instead of over there, but it's really nice, and I want both this course and the school to be as beneficial to the students as possible. So I really do want to know what you guys, not only like physics questions, but I want to know what you guys need to both be successful in this course and at this school. I know the student experience here isn't quite the same as it was a decade ago, but I have more experience being a student here than most of your teachers, I assume. So again, if you need anything, both for this course or not, I want you to tell me. A minor technicality about myself, and I only bring this up because it's a weird thing. I don't quite have words for it, but I feel like if I don't address it, it's like I'm lying. I don't have my doctorate yet. Some of you might have emailed me without meeting me yet saying Dr. Hoffbauer, and I don't want to spread misinformation accidentally. So I'm not technically Dr. Hoffbauer. The nameplate on my office doesn't say that. I'm just Mr. or Professor. Most of my students just call me Mr. Hoff or Prof. Hoff, but any variation of words in my last name is fine by me. I don't know why, but I just really don't want to make people think I have something that I don't. But I do have my master's, and I aced all these classes when I took them here the first time, so I know what I'm doing. And in addition to being an alum, I'm also just kind of a general nerdy goofball. So I will tell you that one of my favorite parts of this job is when students ask me goofy, off-the-wall, oftentimes fictional questions. Like, say you watched something sci-fi last night and you come in wondering how black holes work, or you recently re-binged all of Star Wars and you want to ask how lightsabers could possibly be built. I love those questions. I want you to ask them. It is my favorite part of my day when I can get off topic for a little while and just either explain something that you might not get to hear otherwise, or muse about how a fictional thing could possibly work. I put way too much thought into trying to figure out how Superman's powers work. Please ask those silly questions. I really do mean it. It makes my day. And if you never take another physics class again, what other chance are you going to get? So please ask them when they pop into your head, both silly questions and serious questions. I really do mean it. And again, it's nice to meet you all. I wanted to also mention another quirk about myself. There's a hole in my brain where names go to die. It is very unfortunate. I have a very hard time remembering names of people, especially when I have 50 plus students in a semester that I meet all at once. It's very unfortunate. I do apologize if it takes me time to remember your name. So just sorry about that. If you want to introduce yourself to me with your face and name, I would appreciate that, but it's not required. Questions, comments, concerns, anything on your mind before moving on?
What's your favorite Star Wars character?
Favorite character. I'm partial to the droids, just because I like robots. I don't know what R2 is saying, but I know he's a snarky little turd. Oh, ooh, okay. This is a weird, this is kind of a deep cut. There's an MMO, a Star Wars MMO I played. The Old Republic. I keep getting the Old Republic and Knights of the Old Republic mixed up, but in the MMO, there was a different astromech droid, I think T7, who is just wonderful. He's the most helpful and friendly little guy, and the game thankfully translates all of his beeps, so I actually know what he's saying, and I know that he is just wonderful. So I'm gonna say T7, for lack of anyone else right now in my brain.
Will you teach us how to play D&D one day?
I can. It's not on the syllabus though, so that might have to be like, at, you know, in between classes. But yes, I can do that. I will say the caveat though, I'm really only familiar with 5th edition. So if you want to play Pathfinder, you're on your own. Anything else in your minds right now? All right. So now it's time for the boring technical stuff. We're going to look at the course syllabus, make sure you guys understand how the course is going to work, and then that'll be pretty much it for today. I keep my syllabus on Brightspace, so now let's start looking at the course Brightspace page. Computer, please. Now, thing to note about this class's Brightspace page, every semester I always have just a time getting everyone into the Brightspace page. The reason for this is because there are 4 sections of Physics 1000 that you picked one of when you registered for this course. And that is because there are 2 different lectures. There's the E lecture that was right before this class, 10:30 to 11:30. And then the F lecture, this one, 11:30 to 12:20 technically. And separately to there being 2 lectures, there's also 2 different labs. There's the Tuesday lab, which is code W, and the Wednesday lab, which is code V. And so the way that the physics department does that is between those 2 lectures and those 2 labs, there are 4 different sections you could have signed up for, each a different combination of lecture and lab. So if, say, you attend the Wednesday lab and this lecture, your schedule would say FV. So 4 different sections, each with those different combinations. And that means that between those 4 sections, it always takes me effort to get all the sections routed into my one Brightspace page. So if you log into Brightspace and you don't see this, Hofbauer, the physics of how things work, spring 24, I need to make sure you get in here. It's okay if you're not right now, like there's nothing you need to be doing immediately, but I need to make sure you're in here. So if you log into Brightspace and don't see this, I need to know. And since again, I'm awful at remembering names, and if you ask me to do something, there's a chance I'll forget it within 2 minutes, I need you to email me if you're not in there. This is my email address, jahofbau@presby.edu. If you email me things, I get it sooner, and then I can have it physically there written so that I can act on it. So any questions you have at any time, any needs you have at any time, it's a great idea to email me. Because I will see it, I will get it, I will reply to you as quickly as I can, and I have the written record of it that is good for my brain. So I guess your first instruction, your first assignment for this class is, if you are not in the Brightspace page, please email me from your Presby email address so that I can make sure you are added to it. Sound good? Okay. It's okay if you're not in it yet. Again, there's no assignments you need to be working on right now, but You need to make sure you're in there so that you can get them all eventually. If you are in the course, or / when you are added to the course, there's currently 2 tabs here. The course changed textbooks, so I'm in the process of rebuilding all my Brightspace stuff, rearranging all the chapter numbers, for example. Right now, let's look at the Introductions and Resources tab. When you click on the tab itself, we've got some basic information about the course. For example, classroom number. The room we're in right now is Richardson 115. So when I say 115 or the classroom, I'm referring to this room. Excuse me. This page also has some general tips for passing this course. Every other tip is ask questions. I really do mean it. That's what happens when you click on this tab. I'll mention that as I add tabs for each chapter, for example, the chapter 1 tab, when you click on the tab itself, it'll list homework numbers. But additionally, there's also a document that will have the questions as well. So there's a couple different ways to get to the homework assignments. And that's what the chapter tabs will start to look like. As for this tab here, within the tab itself, first we've got a copy of the course formula sheet. There will be a formula sheet, and you'll be able to use it on literally all of your assignments, including tests and exams. You do not have to memorize any formulas. The reason being that I know from experience, if you were working as a physicist professionally, you'd have a bunch of reference materials at your desk that have the formulas in them. So professional physicists don't have to memorize all of them, therefore, neither do you. You will have a formula sheet that you can use on everything. I'm in the process of reformatting that sheet because changing textbooks means all the chapter numbers are different. So what's currently here is the old one with the old numbers on it, but it's still got all the formulas you need if you want to start looking over things now. But I'm just disclaimer, I am currently reworking it for the new numbers. But you will have a sheet, you can write all over it, you can bring it to tests and exams and use it on everything. It's your best friend. We've also got in here the syllabus that we're about to look at, and also note that I put all of my PowerPoint notes that I use on Brightspace as well, so that you can look at those at any time. This is just the one I was using a second ago, and the chapter 1, like each one will be within the tab that it's numbered after. So you will have all the notes that I use in class and all the examples that I use in class. And then is the syllabus itself, which has all those fun technical details that everyone loves hearing on the first day. Any questions before we dissect this thing? All right. So this course syllabus first says course name, my office location, Richardson 109 E and F. If you ever need to find that office, how to get there from this room is you exit this room, you turn right, and it is the last door on the left, specifically the left. There's a series of 3 offices on the left there for the different professors. It's E and F because the one office has 2 rooms versus a lab space, and that is my office. But you go in the one door, and that's where I would be. Also got my email address again, jahoffbow@presby.edu. Office hours are after lecture on Monday and Friday, and other availability, please email me your questions and your needs and concerns at literally any time. If you can't find me in my office, please email me, and I will get back to you promptly. Your emails route straight to my phone. If I'm not asleep or driving or eating, I will get to you as quickly as I can. And an email is a great way to ask me questions because, again, if I have the written record there in front of me, that's really good for my brain. That's good for my memory. So, email me anything, absolutely anytime. We've also got here a link to the YouTube channel where I post all of the lecture recordings. It's a very boring channel. It's just the place where I post everything, and all of the new lectures will get posted there each day after I have them. So again, if you miss a day, you can come here and watch what you missed. Continuing on down, this room is Richardson 115. I'm realizing I didn't list the lab room on here. This course's lab room is Richardson 126. If you want to get there, it's basically the opposite instruction as getting to my office. You walk out that door, you turn left, and it's the last door on the right before you hit that double door at the edge of the building. And that's the room we'll have lab in all semester. Now, there's 2 lectures of this class, 2 lecture sections, E at 10:30 and F at 11:30. I teach the same thing twice in a row, so I'm in this room saying the same thing for 2 hours. Again, that means that when you enter the room, the last class will be exiting, and I'll be up here resting before I repeat myself. You can please absolutely ask questions during that time, but I'm just taking that time to rest my vocal cords. And since it's the same thing twice in a row, I don't really care which one you show up to. If for some reason attending the other lecture time just works better for you any given day, feel free to do that. As long as there's space in the room, I don't really care which one you show up to. I also really don't care if you attend class at all, technically, because I don't take attendance. You're all adults, you can manage your time, and people are going to get sick, people are going to miss days because of sports and illness and mental health days, honestly. You should take those if you need them. For that reason, I don't take attendance. You never have to justify not being here. What is your responsibility, though, is learning the material. So if you miss a day, make sure you catch up on what you missed. Look over the notes that I post, look over the lecture recording. If you miss something that is legitimately okay, you don't have to justify it, but you do have to learn the course material. That's the part that's your responsibility. All right? Does that sound fair? All right. Labs. There's 2 lab sections, Tuesday and Wednesday, the same time each day. They'll be in the same room, 126 each day. I oversee the entire course, and that means that I write all the labs, but I do not actually manage the Tuesday lab section. Dr. Edwards will be in the room if you attend the Tuesday one, and I'm in the room for the Wednesday one. It's the same lab both days. And unlike lecture, where you can crisscross and miss any day that you need to, you should attend the lab that you are scheduled for, because there's a certain number of chairs in the room. It's designed for a specific number of people, 6 tables, groups of 2 to 3. And if you do miss a lab, that I need to know about. Because if you miss one and never make it up, that's just a 0 sitting in the grade book, and that's not good for you. So if you miss a lab, please tell me about it. If you know ahead of time, email me ahead of time, and we'll figure out either when you can make that grade up or what we can do to get you the grade for it instead. So, again, if you're sick, if you're out on sports, don't worry about missing lecture, but do let me know if you're going to miss a lab. If you know that ahead of time, let me know, and we'll figure out what you do for the replacement grade. You can either make it up usually within the same week, but additionally, I also post at the end of the semester a makeup lab. So if you missed one, you can do that to fill in a previous grade that you didn't make up yet. So there will be opportunities to make sure that you don't have a 0 for a lab that you missed for any reason. But if you know you're going to miss one, let me know, just so we can figure out what the best option is for you to get that grade together. Questions so far? Okay. Moving on. Here's a 10-point grade scale. So if you have a 90, you have an A. If you have an 89.99, you have an A. I also do give pluses, which is to say that if you get an 87 that can't possibly round up any higher, you'll get the B plus instead of just a B. I don't do minuses though, so you have the 80, you have the B. And here is the weighting for each of the individual parts of the course. Labs make up 25% of your grade. The 2 tests make up 50%, and the 1 final exam is the last 25%. Labs are here because, unlike other departments on this campus, lab is a part of this class. This is one 4-hour class instead of a 3-hour and a detached 1 hour. So it's one 4-hour class, and for that reason, Labs are 1/4 of your grade in this course. That means if you miss one and don't make it up, that's 2.5% of your grade gone. So make sure to make up your labs. There's going to be 2 tests throughout the semester, and that means that each single test is about 25% of your grade, same with the final exam. They're weighted this way such that if you have one bad day and just don't do well on a test, it is not going to be the end of the world. If you got a 0 on one test just completely wholesale, you could still get a 75 in the class. Same on the final, actually. And it's also pretty much impossible to get a 0 on any of my tests because I give you partial credit for literally everything you write. So I will often, as hyperbole, mention here's what would happen if you got a 0 on something. But the only way to get a 0 on one of my tests or the final is to leave it blank. As long as you write something, preferably an actual attempt, but as long as you write something, you'll get points. Drawing a picture of a smiley face isn't the best answer, but it's at least an answer, you know? And an answer is worth more than none answer, if you catch my drift. Moving on, textbook looks like this. It is technically optional. It is recommended to have your own physical copy, especially if you like, or digital copy, if you like having reference information, especially because this might describe something in different words than I use. So it's a good reference book, and the homework is in it. But I also post the homework to Brightspace so that you can do it even if you don't have a copy of this thing yourself. So recommended, but not absolutely required. What is absolutely required is some form of scientific calculator, because again, this class has math in it, and you cannot use your cell phone or your laptop as your calculator on a test. So you need some form of calculator that is not connected to the internet. It doesn't have to be one of these necessarily. It doesn't have to be a Texas Instrument with graphing functionality. When I say scientific calculator, I mean it has to be able to handle exponents and trigonometry. So squares and square roots and sine, cosine, tangent. So as long as it can do those things and it is not web enabled, it's legal. But it has to be not your phone or not your computer and not web enabled. So you have until test 1 to locate something like that. I haven't taught in a month over winter, and I feel like my voice is drying out faster than usual. Turns out your vocal cords are a muscle. Also, the air is dry. That doesn't help. Next is the list of topics to cover. We're going to start off with motion, forces, Newton's laws, the sorts of things that you've definitely been noticing throughout your entire life. And then we're going to move on to slightly more esoteric things like energy and gravity, and eventually at the end of the course, waves and electricity. We're going to go through a bunch of different concepts, again, so that you can get a base understanding of the science of those concepts, and we'll talk about why each of these things are important to your life on this planet, even if you are not a scientist. So a very wide range of things. And again, any random silly questions that pop into your head, I'll tie it into the course somehow. For example, I get asked about black holes a lot. Literally, that's just gravity. I'll make it relevant somehow. Questions so far? All right. Page 2 of the syllabus goes over all the different types of assignment. First up is how the homework is going to work. You may notice that while I do assign homework, if we scroll back up to the course grade weighting, that's not here because the homework isn't graded. It's not a requirement for you to be constantly turning it in for grades because I don't grade it. The function of the homework for this course is basically the study guide to the test. And to that end, I do model the test around the homework. So if you can do the homework, you will be good on the test. I even pull very specifically 1 or 2 questions directly from the homework to benefit the people who take the time to do it. Every chapter that we have, I'm going to list homework questions that do come from the book. So for example, if I look at the Chapter 1 tab real quick, clicking on the tab itself. I list here which homework questions from Chapter 1 in the textbook you should be able to do. Note that they are odd-numbered ones, so the answers are in the back of the book. But furthermore, you don't even need to lug a book around with you, because I also post within each chapter tab copies of the questions. So you can look up the numbers in the book, you can also look at the document that I post, and whether you use the book or the copy here, the answers will exist for you. Because again, the purpose of the homework is for you to practice. You try it, you check your answer, you keep working on it until it makes sense. And you don't have to worry about turning it in for a grade, and then I don't have to worry about grading it quickly to get you your feedback. So you already have the answers. And I also encourage you to work with each other on the homework. We also have tutoring sessions, so work with each other, come to tutoring. All of it is good, valuable resource. As long as you are working on the homework and practicing, that is studying. That is making sure you are prepared for the test when it happens. And honestly, working on it with each other is good for everyone involved, because say if one student gets it and another student doesn't, the first person benefits from, I find that if you can explain something, that's the best way for you to understand it yourself. Like if the first person takes time to find the words to explain it, that helps them. And the second person is benefited because now they can do the question and keep practicing it. So homework is group work, totally encouraged. And you have the answers to check and go over. There'll be a number of questions listed for each chapter. I'd recommend, say, before test 1, for example, go back to the syllabus. I'll always tell you before a test comes up what chapters are on it. Come on. Scroll, please. For example, test 1 is tentatively about chapters 1 through 7. So as you're studying for test 1, make sure that you've worked on those chapters and the homework from it makes sense. Questions about that? Okay. Now, looking at the things that do count directly as a part of your grade. First is labs. There'll be about 10 labs throughout the course. We won't have lab every single week. For example, no lab this week. On the weeks there are a lab, you should report to lab at the time and date that your schedule advises. You'll be in there working with a team of 2, including yourself. You'll be at a table of 2 to 3 people working on the experiment and the objective for that day. You don't have to prep anything ahead of time. You show up, you do the thing, and then you go home. Your group will make the one lab report on, not even a report necessarily, you've just got the experiment, your data, things you're asked to calculate, and then related questions. We'll talk more about the general flow as we start having labs, but they're all self-contained. You don't have to do anything for prior, and you don't have to do anything for after you leave. Just hand it in, and that's going to be it. Again, there won't be lab every week. I'll make sure you know ahead of time if you have lab that weekend to show up as normal. And again, if you miss one, if you know you're going to miss one, let me know. And even if you don't, if you miss one for any reason, we'll figure out how you're going to make the grade up. Now tests. We're going to have 2 normal tests throughout the semester. I've gone ahead and written the tentative dates I have scheduled for them on the syllabus. Subject to change if things in the course develop in a way that I don't expect, but these are the tentative dates that I'm planning around. Each test will be about the specific range of chapters covered up to it. Test 2 does reflect back on test 1 because I did mention that every concept kind of builds on the last one. So each test is cumulative to what we've talked about up to that point. And again, I list here not only the dates, but also the range of chapters whose homework you should be familiar with before taking it. The way that I do the tests is I actually give them during lab time. So it's less of test day and more of test week. Note, each of these tentative dates is actually 2 numbers, and that's because there's one lab section on Tuesday and one on Wednesday. The way that a test is going to work is on the week that we give that test, lecture will be focused on studying for it, looking over homework questions from you guys, making sure everything makes sense. And then on whatever day you would have lab that week, instead of going to lab, you would come here and you take the test in here during the time slot you would normally have lab. I like this because I write the test to take about an hour, and it doesn't feel fair to me for someone to have to rush in and take an hour-long test in 50 minutes and then rush to another class. That's just not good for anybody, especially if you've got academic accommodations. So what I do instead is, you come during lab time at 1:30, and then you have 3 hours to take a 1-hour test. So you don't have to rush in, you don't have to rush out, and you would have already had lunch, so you don't need to worry about not having eaten. So, and the way that when you show up for the test, again, you will have access to your formula sheet, you'll have access to your calculator. You can also have access to whoever is proctoring your test. Either me or Dr. Edwards, again, because he does the Tuesday labs. We'll be at the front of the room, and I want you to ask questions during the test. At the very minimum, make sure you understand what's being asked of you. So if you're stuck, ask questions. And furthermore, however many questions are on it, there will be more questions than you need to get an A. I usually have like 105 points graded out of 100, and you get partial credit for everything you write. So again, the only way to get a 0 on one of my tests is to leave it literally blank. I'll make sure everyone's familiar with them and comfortable with them as test 1 approaches mid to late February. The exam is basically just a long test. It's formatted the same way, and similarly, you have your formula sheet, you have your calculator. There's 210 points graded out of 200, partial credit for everything you write. So it's really just a bigger test at the end of the semester. The times for that are also listed here as well. How do you guys feel? All right. Yes.
Are your tests a combination of like multiple choice, should I say, like long answer?
Because of the textbook change, I'm in the process of rewriting all of them. I historically have not done much multiple choice, but at the minimum there will be concept-driven questions. I'm working on putting more multiple choice options, but it'll be split between concept and math.
Okay.
Does that answer the question?
Yeah.
Anything else on your minds right now? All right. Page 3 is tentative schedule for the course, week by week, talking about the things we're going to be covering. And again, it's got the tests and spring break and stuff on here as well. Again, subject to change if anything I'm not expecting happens, but a rough outline at least. And then page 4 is, actually page 4 is the same tips that are in the intro tab itself. Again, every other tip is just please ask questions. I bring it up a lot because I find students just not asking them for whatever reason, which is fair. Sometimes you don't want to speak up in front of people, or sometimes you don't even know what you don't know, which is fine. But I want you to ask them when you have them, even if you're emailing me at midnight. I promise I want to help you. I'll get you the information you need. And the last page is useful accessibility and etc. information that everyone at the school needs and should have on their syllabus. So, how do you guys feel? All right, that's pretty much it for today. I want to say again, physics is kind of inherently tricky because again, we're trying to look at the universe and make sense of it with words and numbers. But I want to be your ally in helping you overcome this class. I don't want physics to be scary. I don't want to be scary, even though I'm giving you a bunch of words and big words with numbers. But my goal is to help you understand the physics you already know and help you pass this class. All you got to do is ask me your questions, give everything a fair shot. Fair deal? All right. On Wednesday, we're going to go over all the intro math and the scientific method. Let me know if you need anything. Again, please email me if you're not on the Brightspace page. And have a wonderful day. It's nice to meet you all.
Do we email you with like from you like the class times or anything?
I really just need your name and your email address. But if you include the other information, it doesn't hurt.